Okay, factorising using highest common factors. First thing we do when we started factorising. Basically, we're just looking for the highest common factor which goes into every term. So, if I have 3, 4, 5, 6, 7, 8 terms, it doesn't matter. You just want to see if there is a number that goes into all those terms. So if I wanted to take this as an example, so I just want to find out, is there something that goes into all three of those? Well, I should be able to say straight away that there's something that goes into all of those numbers. If I look at the numbers, I've got 3, 9, and 27. 3 goes into 3, 3 goes into 9, and 3 goes into 27. So I can take that out and put that out the front. So I've got 3 as one of my factors. And the other one is then I'll look at the letters, whatever is there. And here I've got x cubed, x squared, and x. Well, obviously, x needs to go into all of those. Does it just go in once? Well, yes, because I've only got one here, right? So you just look for the smallest one and then see if how much it goes into the other one. So same thing here. 3 is the smallest one here. Does 3 go into all three things? Yes, it does. So just going to take that out. So I'm actually taking out 3x as my highest common factor, and then I take that out of the first one. Remember, it's taking out, I'm just dividing. So 3x cubed divided by 3x, 3 would cancel with 3, and x cubed, I'm minusing one index there from it because I've got one x there, so that means I've got x squared. Okay, and then I do the same thing. So I've got minus, want to leave the signs the same, and then I go 9 divided by 3, well that's 3, x squared divided by x. Well, remember when we look back at our index laws, obviously I minus my indices. So 2 minus 1 will just leave me x. And then I've got 27 divided by 3, that's 9. Don't forget our sign stays the same, unless I take a sign out here at the front. Unless I take a sign out here, the signs are going to stay the same. So that means I'm left with 9 and no x's because the x is gone, and that's it. Finished, fully factorized. Sorry, fully factorized for this one because I can only take out a highest common factor. So what if I have an example like this one where I don't actually have a highest common factor in all 4 terms, but I have got it across 2 terms. So the first 2 terms here have a highest common factor, and these 2 terms have a highest common factor. By the way, there is CX. Okay, so that means that I've got, in the first 2 there, I've got 2ax minus 8ay. Well, the highest common factor there is going to be 2a, so I'm going to take it out, put it out the front, and I've got what's left. So 2ax divided by 2a leaves me with x. 8ay, remember the subtract sign staying in there, divided by 2a. Well, 8 divided by 2 is 4, and a will cancel, so I'm left with y, because I've only got a single a there. Okay, so this one, cx, negative cx plus 4cy. So I'm going to take out a minus. If I didn't take out minus, I would be left with negative x. But what I want to do is I actually want to get the same as this. I'm looking to make it so that my bracket will be the equivalent, because then I can factorize even further. So if I take out the minus c, then I'm left with x minus, got to change the sign because I've taken a negative out and I want it to stay as a plus. Minus times minus will give me the plus. I've got 4 and y. And now that I have taken out that minus, I actually have the same thing in my brackets. And that thing is called a binomial factor. And the binomial factor comes then to the front, because I'm taking out again, take out the highest common factor of those 2 terms. Well, I've got one. What is it? It's this thing here. So let's move it to the front. And then I say, well, the highest common factors go into the other bracket. The highest common factors are the factors I took out to begin with, right? So these are my original factors, and they will make up my second bracket because they're actually both being timesed by this nice little factor here, right? So if I take it out, I need it to be in a bracket because they were being timesed. So I've got 2a minus c. And you can check it, right? If I actually had 2a times this whole bracket, that's what I had as my original term, and minus c times this whole bracket, that's what I had as the second part here. I can go backwards and check if it works, and then you expand, and then you expand it further, and I'll be left with this. Okay, so that's it for highest common factors. If you want some practice, 2.2 in the textbook, goes through factorising using highest common factors. You can also look at the chapter review at the end, or the practice tests will have some examples on highest common factors.